So anyway, I'm comfortable and I prefer that if you have a question that you ask it right then, and I'm not, doesn't bother me that you say, I didn't understand what you said, or can you explain that again or a different way or something. That's what you're here for, that's what I'm here for, and I'm very comfortable with that. I don't want you leaving saying, well, I didn't know what he was talking about, but you got to ask, okay? What we do here in the planetarium, the science theater, is the last Saturday of each month throughout the year, with the exception of October, November, December, because of Halloween, Thanksgiving, and Christmas. Other than that, the show is on the last Saturday of each month. Now you will be able to go on our website, and once we start here, you will see I'll pull that up with the slides and show you how to get the information that I'm talking about and that you can use. We used to take and print out the material and hand out to people, but thanks to Mr. Fernandez, our technical expert, we now have our own website, blog, and the information is there on the blog we call the Astronomer's Blog. And you are you go right ahead, you get on it, you can download and print out all that you want. And as time goes on, I'm adding more and more material to it. So I believe we're about ready. Let's take down the lights. We'll get started. And glad that you all are here. Before we get real dark, how many are first timers? Hands up, hands down. Very good. Good to have you here. Make us a habit, if you will. Okay, here we go. When you go on our website and you type in, as you see up here at the top, our website address is www.starsatnight.org, and right there. And here's the kind of picture that you will get when you do that. What you would do then is the next thing is to go, and depending upon the size of your screen, your computer screen, the blog may be over here or it may be here. But anyway, on this case, it was right there. You just scroll to blog and you'll see these three are listed. And for this, if you go then to the Astronomer's Blog and you click on that, here's what you will get. And this is as of this afternoon, this evening. And you can see the different things that so far I've added. There's 4 pages of this at the present time. There will be more coming. What we will do this evening is we will scroll through the February calendar. What I do, since this is the last Saturday of the month, what I talk about is next month's constellations, the major stars in those constellations, and other information there. In other words, to have you to look forward. As time goes on, different things will be updated. If you'll notice, the 8 January constellations that I had in there was some additional material and some changes, and so you can go on that. They are going to just be listed as a blog chronologically, and you just scroll down until you find what you want. Now, for instance, here on the calendar, you go to it, and here we have, and it starts out, and just like here, week 1, we'll go through week 2, 3, and 4, and go on down. We will discuss each of these items as for the week as we go through. Okay? So for Sunday, tomorrow, the 1st, there's a lot of things that are happening on that first day. And as a reminder, not only to myself but to others, a date day starts at midnight. So tonight at 12:00 and 00 seconds is when February the 1st starts. And that's when we go. Now, we notice here, it says it's the best night of the year to view the constellation Carina, named as the keel of the ship Argo Navis. Actually, would be, and you'll see later on, that I recommend that you start the sunset of the day prior, the night prior, and then go through the next morning. But let's take a look here, if you will, at Carina. So you would go back on the website, you would scroll down, and you're going to find Constellation Carina right there. There's 2 pages. You click on that, and here is the first page. Now, and all of this, of course, you'll be able at home, wherever you are, you can download that. Carina is a relatively large constellation, and it's in the southern hemisphere, as you can see here from the negative numbers. Where we are here at the Mayburn Science Theater here at Killeen, we can see, if you want to say, down to approximately 58 to 59 degrees southern hemisphere. So here's the -50, here's -60. So if you took, and this first come across, about the top right here is everything up here is what we can see. The only thing that we will be able to see here will be this one star called Canopus, the third, pardon me, the third brightest second brightest in the night sky. And all of these others are going to be below the horizon. The only way you'll be able to see them would be to travel south and get down quite a ways for you to be able to see the rest of them. Here is the second page that's on for each of the constellations. You can see there's a lot of different information. See up here it says best night for viewing, beginning at sunset, January 31st, ending at sunrise, February the 1st. And then here's additional information that's on there. Let's take a look at some of the things that is in Carina. Here is what they call, as you can tell, the Southern Pleiades or the Pleiades. And it's this little group of stars right here, not the big group, this little group right here. And it may be a little difficult to figure out, but these are much closer than all of those back in there. Now we are looking, all of this is in our own galaxy, our Milky Way galaxy. And so we are looking through it, into it, and these are some of the things we can see. There is the northern Pleiades, the Pleiades, that we will begin losing probably in maybe a few more days, and that's it until again in the fall, and it's primarily for us to see that in the winter time. So here we have. Here's a close-up of it, of them, if you will. As you can see there, each one of those. By the way, just think of this. Remember, every single star has its own solar system. So, every single star has its own solar system. Every star is a sun. Every sun is a star. Here's some more. Here is also called, as you see, the Southern Beehive, another group right here called a cluster, as you can tell. By the way, NGC, For those who, that's called the New General Catalog. And the astronomers have run out of names for these different objects, so they've gone naturally to numbers. And all that is, it's the 2,516th one to be added to the catalog. It's not the 2,516th largest, farthest, closest, biggest, or whatever. Here is an interesting one, this one here, Eta Carinae Nebula. Nebula is Latin for, who would know what the nebula means from Latin into English? Cloud. Very good. It means cloud. And so the cloud can be either gas or it could be solid material. We will see examples of both as we go through looking at different objects. Down in there, this star, that's the Eta Carinae, that's the name of the star, exploded some years ago, and it has begun, it shed some of its material. And here we have, this is what has happened. Now I don't have the dimensions on here, but we are looking at light years across this. Not just a few miles, but trillions and trillions of miles. And they are still expanding still at the force of the, we'll say, the explosion that is going on there. There's also, here's another nebula. You can see here, this looks gaseous here, and we'll get some that are have some solid material that's there. Now here's more of the solid, like so. These are also called the pillars of creation by some, and these are light years in length that we have here. And as you can tell, definitely here, these wisps of gas, that would be nebulae, plural there. Now, sometimes they come up with names, and okay, this is called the wishing well. I'm not sure where it is, or what whoever saw that would name it. But as you can tell, there are a few stars there. Okay, so that is Carina. It has 5 bright stars, 3 of them for navigation, 3 of the Caldwell objects. And as I said there, that viewing from here, we can see only the top 8 degrees of Carina. Now, at beginning tonight, here you would notice the clouds go away. The moon is already up, Jupiter is already up, and then here as the time goes on, in a little while, at approximately 2:38, looking on the eastern horizon, Saturn will begin rising from the eastern horizon there in the constellation Scorpius the Scorpion. At 5:29, the moon is going to set below the western horizon. So that would make me think that in just barely 5 hours, and so it takes maybe 12 hours for the moon or something to go across the sky. To look for the moon, I want to look to the western side. I don't want to look at the eastern horizon. And then we also see that later on, Mercury is going to rise here. And then we have sunrise at 7:22. So let's scroll down and look at the rest of the day of tomorrow. And we have at 7:52, we'll hear from sunrise, and these are things that are happening, but we're not going to be able to see them because it's the sunlight is up. And what we have, Jupiter sets, you can see Venus, Mars, Uranus. Uranus is the farthest planet that we can see with the naked eye. When I say the naked eye, what I'm referring to is you look in the sky and you do not use binoculars or a telescope. And so on a certain time of the year, excuse me, you can pick out Uranus if you know where to look, and the night conditions have to be virtually perfect. No moon, far enough away that there are no lights bothering you from any town, village, city, or anything else around. You have been out there long enough that your eyes have what we call night sky adjusted. And you also know where to look, because Uranus will only look just like a little bitty teeny star. And it's in Pisces, the fishes. And since it is so far away, it will remain in that constellation for about another couple of years. Then we have at noontime, when we look at our watch, it says noon is 12 o'clock. But then it says that the sun transits at 12:44. That's when it is transit, means it is due south of us. We'll discuss this, what's the difference, why the difference, in a little while when we get to that part of the calendar. Here we go in the afternoon. As you can see, Saturn's setting, moon is rising, Mercury sets, and then we have sunset. Now it's going to start getting darker, and we should begin to see, and here we go, Jupiter rises for us. Going to come up again. Venus, Mars, and Uranus. All right, that's the first day, Sunday, tomorrow. And we'll talk about that. Next week, or the remainder of the week, Monday, here's what we have is going to go on for the week of February. Candlemas, Groundhog Day. Okay, so I'm not even going to try to remember the name of the groundhog up there. And I think it's Massachusetts, isn't it? Or Connecticut, or someplace up there. Pennsylvania, okay. It's also called a cross-quarter day of the year. And here's what that means. This day is halfway between the solstice and the equinoxes that happen throughout the year. And that's what we have. Some people want to say that these cross-quarter days would be a more accurate time of the year to say when one of our seasons begin, rather than December. Here we see on December 21st that winter began there, that it would wait until it actually begins later on. Now we have another constellation, Camelopardalis, the giraffe. So you would scroll down on the website. Here it is, looking at the 2 pages. Here's the first one. Now it's a strange name, Camelopardalis, and it's named after a giraffe. Now why would they come up, if they're thinking this is a giraffe, why would they come up with this name? Now, all names are Latin, okay? So, what's the first part that you see? A camel, okay. Now, what is in the Middle East, there, in Arabia and over in there where a lot of the history, if we have, of astronomy is, the camel was the largest, pretty well, of the land animals that they were familiar with. And you have the 2 kind of camels, the dromedary and the Bactrian. And so they were told, and when they saw this, they were thinking that this giraffe, which is much larger, of course, must be a relative of the camel. Now, what is the color of a giraffe? It is spotted, and what colors? Yellow or, okay. What else, other land animal do we know that is spotted and can have yellowish colors? Cheetah. And what else? Leopard. Okay. So they were familiar with leopard. Cheetah, maybe not. And so they said this thing is a camel leopard. Camelopardus. Okay? And we will find it and look at that later on here. Here's page 2 of it, some information that you have there and that we have. Here are a few things that are in it. This one called an island universe. It is another galaxy. And you can see it's a little far distance away. By the way, for interest, this APOD, A-P-O-D, Astronomy Picture of the Day. That is a website, and if you just type in on your search, why does it look like the Milky Way? Because it is another galaxy, like our own Milky Way. And so here would be the center, and here would be the spiral arms, if you will, of additional stars of this galaxy. Good question.
How do we see this galaxy so far away?
How do we see it? With telescopes.
Didn't we have like more telescopes? Because a regular one can't see that.
Well, we don't have one here that could see that. Most of these are taken from Hubble, our space telescope, and other professional and hobby astronomers that have very large telescopes. Anyway, if you go on the web and just type in your search APOD, it will come up. This has been going for about 20 years. Every day there is a new picture that is posted. And you can go on it and you can do a search for specific items, or you can just start scrolling through and looking at the pictures that are there. And many of them are quite amazing. And it's a free thing for you to look at. Here we go, another one. Now we are looking, these stars, all of this would be in our Milky Way. So we are looking through our Milky Way out beyond, and there are 7 million light year miles, if you will, trillion light years, that is in between these stars and that galaxy right there. There you can see the core and the concentration of the stars and the spirals that come around. Okay, we come next. That was on Monday. Tuesday, here's what we have. We have a full moon. And you notice it says no lunar eclipse, something about the moon. Okay, well, let's take a look. Here's the sun, of course, and with its light. And for a full moon, the moon has to be on the opposite side of us from the sun. The sun, earth, and then the moon. And I get questions, how come, since the moon goes around us every month, how did we get the name month? Moon, month. So, that goes around 12 times a year. How come every time we have a full moon, we do not have an eclipse? Well, here's why. The moon's orbit as it goes around Earth is tilted. Now, this is exaggerated, but it is tilted in relation to the way we move around the sun. And our shadow is constant out beyond us. And so as the moon comes around and it comes in the position right here, directly in line with the sun in this direction, but it's not directly in line with the sun in this direction. So in this case, no lunar eclipse because the moon happens to be below the Earth's shadow, which is always out there. Okay? I hope that helps you understand why we only have a few eclipses every year. All right, also on Tuesday, we have another constellation, Pyxis, the compass of Argo Navis. Now, this is an ancient constellation called Argo Navis, and it was a very large one, and was decided to be split up into different constellations. And so we have seen already one. There'll be a couple more that we're going to have here. This is the compass. Let's take a look. We scroll. Here it is, 2 pages. And here we have it. It is a southern constellation also, not as far south as Carina, but here it is, not a whole lot as far as naked eye for us. Here's the information. As you can see, here's visual, or back up here we have of the 100 brightest night sky. Pyxis does not have any of the 100 brightest night sky stars there. So let's take a look. Here's a few things that are in it. A planetary nebula. Now here's the nebula here. Why is it called a planetary nebula? Well, we have to think that it wasn't until the 1600s, middle 1600s thereabouts, that the telescope was invented. And when Galileo took some glass lenses, put them in the proper order inside a tube and looked up into the sky. And that was the beginning of telescopes and astronomy in that sense. As time went on, the technology has improved. Well, initially, back in the 1600s, the 1700s, the early 1800s, the telescopes they had, of course, are not what we have today. So when the astronomers looked in the sky and they saw a round, glowing something, they said, that's not a star, that must be a planetary nebula. Planet there. And then anyway, as time went on, they were able to find out it wasn't a planet at all. It is a gaseous cloud that we have. Not a whole lot in there. Okay, Jupiter, as it moves, the planet moves, it's going to enter the boundary of the constellation called Cancer, the crab. And then we're going to have an apogee moon. Well, what's that? Let's take a look. Exaggerated, but the orbit of the moon around Earth is a circle, but it's not a perfect circle with a one constant radius. It is an elliptical, it's an egg-shaped, if you will, an oval. And so there is a time in each orbit where the moon is farther from the Earth than at other times. And so that's called the apogee. And that's what we have here. Now we go on down. The next is, it's at noon, but we can view it that Friday night, the 6th. Jupiter is at opposition. Well, does that mean it voted against something? No, it's not voting. It's talking about its its position. And notice, this is the best night of the year to view the planet Jupiter. Let's take a look. What does it mean Jupiter is at opposition from the sun? Well, there's Earth, here's our sun, and there's Jupiter. What it means is that Jupiter is going to be like the moon at a full moon. Jupiter will be positioned opposite Earth from the sun, like so. So on that night, when you look, we look out there, ideally it's going to be the best, it'll be up all night, and at midnight is when it's the best. And so, in essence, when we look at Jupiter, just like we would have a full moon, we would have a full Jupiter. How about that? And if you were able to travel to Jupiter and look back at the Earth, what would you have? A new Earth. You see how that was? Like if we had a new moon here, that we're looking back, we were on the moon, we looked at it, looked at Earth, we'd have a full Earth. So anyway, that's why it's called an opposition. Let's go on. Now we also start this time of the year, we will start what's called zodiacal light, zodiacal light, and for about the next 2 weeks. And here's kind of what it's going to look like. You will look to the here western horizon after sunset. So after sunset, you would look and you will see a faint glow in the sky, looking kind of like a pyramid. Now we're not going to have the Milky Way showing up very like that, but anyway, that's what we have. What this is caused by is that in our orbit around the sun, that it works that we're on the plane of the ecliptic, such that all of that other material that's in our plane with us going around the sun will glow, and the sun is making this glow. The sun is already down. Okay? And then it says on that February, and I went ahead to put it in because it's possible you may see a few of the meteors, but the actual center point, or called the radiant point, is below our southern horizon, just barely below. So if you look that night, starting sunset through sunrise, you would look to the due south, and you may see some meteors down in there. Okay, week 2. Whoa, that's a busy week at week 1. Week 2, we start off and it says the equation of time is at minimum. What in the world is that? Let's see what we have. As we go around the sun, in relation to that, as we orbit around the sun, and let me back up here just a moment so you can see, I want to get to there we go. Say that this is the sun, and this is us, this is Earth. As we orbit around the sun, it's a full circle, but just like the moon going around us, our circle is not a constant radius. And so there's a certain time of the year when we are farthest from the sun, and another time when we are closer to the sun. And so as we go around in that, also another thing, the farther you are away from the sun, the slower you go. But as we come and get closer to the sun, because of its gravity, we begin to speed up and go faster until we start slowing down again. Now, it would be very awkward for us to try to reset our watches every day so that when it said 12 o'clock noon, that the sun was at high noon in the sky. So the astronomers and scientists said, we can't do that. The people would rise up in arms. So let's take the average speed of our Earth around the sun, and we'll average that, and that will be what we'll use as our reference for our high noon. So let me click on back down through here. And we see that it says that with that, in plotting, it looks like this. There's a lot of other variables, but this is what happens when we speed up and slow down. Notice we are in the slow down time, the shading down here. In fact, we are, this February, we are the slowest. So what would you think? Are we close to the sun or far from the sun? We're far. Now, in relation to that, I usually ask, and I did back in the January time period, there are two, as I mentioned, there are 2 times of the year, one when we are the closest to the sun and one when we are the farthest from the sun. The closest to the sun and farthest from the sun happen in the months of January and July. So tell me, someone tell me, which month are we closest to the sun? What month, January or July? What would you think? Pardon? Well, we would think, that's a logical answer, we would think it's July, but that's not correct. We are actually closest to the sun in January. But the thing is, since we're in the northern hemisphere, we are tilted away from the sun. You see? And so that's our winter. If we were in the southern hemisphere, if you were down in Australia, Africa, South America, down in there, New Zealand, you would experience their summer right now, and it is a hot summer. So it does seem backward to us. But anyway, here we go. Let's figure this out. We see the equation of time, it says we're 14.25 minutes slow. In other words, we have high noon at 12 and the sun still hasn't risen up to high noon. What is going on? We got 32 minutes we got to figure out. Let's go to that real quick. The Earth, as it rotates, the time is based on the central time meridian of our time zone for here for central. It goes north and south right through New Orleans, Louisiana. And we are 7.8 degrees to the farther west, which means we're after Louisiana. That comes out 4 minutes time, comes out to then that we are 31 minutes in rotation time behind Louisiana there in New Orleans. And if we add in this, and based on our latitude to come up, we see that we get about 32, and we add a little more, and it comes up to 1246, and that's why. And here, this is another chart that's available on the website. Here's February, all of the sunrises, transits, and you can see the other. Here's February the 11th, and the transit is 1246. Pay attention, a test will follow. Let's go on. Mars enters the region of Pisces, and we come up to a last quarter moon. We've already had the full, and the moon continues around, and we have our third quarter. So at that time, both the moon and Earth are the same distance from the sun. We now come to Friday the 13th. Oh, wow. And we have the constellation Vela, the sail of Argo Navis. Scrolling, here's the first. And we are fortunate, we are able to see all of Vela. We will see all of it. And here are 1, 2, 3, 4, 5 stars, and there is one object in there. And if you see, it's a Caldwell naked eye object. Another astronomer came up with some what we call deep sky things to look at, and so these are listed. And here's the information on the 5 stars there. Let's look at some things in there. There's a cluster, primarily this right in here. Well, what would you call this right in here? Nebula, very good. That would be it's a nebula. And this is based on the lens of the telescope that it's going to cause this to glow like that. Another nebula, the Pencil. Another one, a supernova remnant. It blew up, and this is parts of it. Let's go week 3. Let's speed on through here. Venus enters, the sun enters. Let's go down. We're coming up. It's time for the new moon. We see the word lunation, 1140. There you can see there is an astronomer, a scientist who wanted to keep track of how many times the moon goes around Earth, and so he started on the first time around in 1923. The moon has gone around 1,139 times. Wednesday of this next month, February the 18th, it starts its 1140th time. Here's our new moon. Again, we also say on the new moon, no solar eclipse. Oh, why? Because in this case, the moon has come around and it's above, and Earth happens to be below the moon's shadow. So there will not be a solar eclipse here on Earth. Let's go on. We have a perigee moon. Remember, we had the apogee far, we have the perigee close. And also, a little bit, it's hard to tell with just the naked eye, but there are times we would get the close moon, and we will get what are called the super moons. And we'll have some of those later on in the year, and I'll be mentioning when those are. Let's go on. As we've interesting thing on Saturday evening, the 21st, starting at sunset through there until 8:34. Now, here's what we have. Here is the sun. This is 6:23 that night, and the sun, and up above, we're going to have you'll have the moon, and if you look down, kind of hanging down from the moon down toward the sun, there'll be a bright object there. The bright one is Venus, and the little bitty one there is Mars. Let's look at a close-up. A little better. Here's the moon, and then here is Venus, and right there is Mars. That'll be that evening for you to take a look at. Now, we're the last week. What do we have? The planet Saturn at a west quadrature. Oh my goodness, all these new names and things. Let's take a look. What does that mean? Quadrature. When a heavenly body is at a right angle to Earth from the direction of the sun. Let's put a right angle. And it said Saturn is at the western quadrature. So it's over here. And what we're going to see, let's back up, and it says we will observe it above the eastern horizon before sunrise. Let's look back and see if we can figure that out. What direction are we moving in our orbit? We're going this way. Saturn is also going this way. And how are we rotating? We are rotating, looking down on the North Pole. We are rotating counterclockwise here. And so as we start looking around, we will see here, before we're right here, will be sunrise. So we want to look before sunrise over here in the eastern sky to find Saturn. Okay. Best night of the year for the last three constellations. First is Leo Minor, the little lion. Not a whole lot there. We'll see it in a little bit. Here it is. There's your info. Here's a few things. Now here is a good name for this object right here. That's Hanny's Vorwerp. 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 By the way, he was, let's see, what was he? Dutch, I believe. So that's why it's called that. Anyway, that means Hanny's object. And at the current time, I believe they still haven't figured out what this is. Okay. Galaxy up there, of course, and that's a galaxy right there. Sextans. Right there, sextans. That's its information. What we have. These. This. A seemingly square galaxy. Antlia the air pump. That's our last one. Why in the world they call it the air pump? Well, in 1930, the professional astronomers got together and said it's time for us to map out the night sky worldwide. And so what they did is they agreed on the boundaries for every constellation. Who in here plays the piano? Anybody play a piano? Good. How many keys are there on a piano keyboard? 88. How many constellations are there in the sky? 88. Very good. Well, primarily most of the sky in the northern hemisphere, the boundaries had been established for many, many centuries. But when they went to the southern, there were some regions that were blank, if you will. And so they scratched their heads and said, we got to come up with some more names. So there are a significant number of the names of the constellations in the southern hemisphere that are what they call modern technology and tools. And this one happens to be the air pump. Remember, 1930. Okay, here we go. There it is. Here's some things we can see. Another galaxy, a dwarf galaxy, they say. And finishing up the week, here's Mercury, greatest elongation. Well, we've had quadrature and good night, elongation. Let's look at this. Here we go, the inner planets, that's Venus and Mercury. And so what happens as Mercury orbits and Earth orbits, that there is a time where Mercury is going to be at a position in relation to us that we call its greatest elongation. It's its greatest distance angle, if you will, from the sun. And so again, the best time to view that is going to be above the eastern horizon before sunrise. Mercury is the hardest planet other than Uranus to see. Now, to help you to find it, where it is, here is at that time, before sunrise, here's the sun. We're looking to the east. Up here is the head of Aquila the eagle. Here's his wings, here's his head. Here is Altair, the eye of the eagle. And if you notice, the three stars are in line, and he or she, the eagle, is looking at this star, which is the tip of its right wing. So you go down here, keep going, you go past these two brighter stars, way on down, and you'll see a glowing object here, and that is Mercury right there. measuring the angle. Here is approximately 5 degrees. From here, if you go 5.5 times, 1, 2, 3, 4, 5.5, you should wind up at Mercury. There we are. We're now finally going around. We have a first quarter moon. Venus is going to skitter across the edge of Cetus, the sea monster whale, that constellation, and then it's going to enter Pisces. And then the last thing we have next month, February the 28th, Saturday, 6:30 to 8, we will talk about the constellations in March. Measuring angles. We cannot measure distance. We can measure angles with our naked eye. Your pinky, approximately 1 degree. Your thumb, about 2 degrees. Middle 3 fingers, about 5 degrees. All of these are at arm's length. 10 degrees, you can see each of those. We can measure angles. It's going to get dark in here. So, to see the dim stars that are going to be projected up here, what we have to do, we must use what are called our rods. Those are the ones you're not using right now. We are using our cones. They are the ones that are sensitive to color. It's going to get dark. What's going to happen, this little graph you're going to see right here, as the time goes on, it's going to come down to a point and your brain is going to tell you that your cones cannot see anything anymore. So an electrical signal from your brain going through your optic nerve in the back of both eyeballs will then trigger the fluid in here, change its chemical balance, and will then sensitize the rods so you can see the dark objects. Daytime, we look at the cardinal in the tree. We put him right back here in the back of our eye on the fovea centralis, the central focus point, because that's where you get your best focus and where we look at things when we want to read and see. But when we want to look at a star, we cannot put a star or something dim on the fovea centralis because we would not see it. Our cones will not see it. You have to get into the habit of using your peripheral or averted vision. Looking into our eye, we would look in the back, we would see that the bird is still back there on the fovea centralis, but we can't see it, it's dark. But then we can pick up in the peripheral vision the stars. If I looked at the star and put it right here, I will lose it. You will see that in a little bit. That should do it. Here are the dates for the night sky presentations. Here we are in January. You can see for the rest of the year. What we're going to do now, we'll start in the north. We'll go with Camelopardalis and work our way to the south. Thank you very much. Let's make it dark. Turn off the projector. Bring up the dome. First one. Now, if you would please, don't turn on your cell phones because that's going to ruin everybody's night sky vision. Just leave them off. You can look at it later. Okay, now, as time goes on, you are going to see more and more stars. Your rods are being sensitized right now, and we are not adding more stars. It's just that your rods are becoming sensitized. Our first one is called Camelopardalis. What is it?
A giraffe.
Giraffe. Very good. So our partners here have traced out for us what the giraffe looks like as we would look to the north. So go ahead. Is it Rebecca? Okay, Rebecca, let's go ahead and who's got the outline? Here we go. There we come. Look out there. It's in a dark region of the sky, relatively, if you will. It's a little hard to see there. So we're wanting to pick up some things to help us to find it, and we're going to look around and see what all we can use that will help us to see it. Okay, let's turn off that at the moment, and we have, if I remember right, we come on and let's see. Are we at the right place? I don't think so. Is it? Because I see something else. That was a test question for me. Okay. CAM. Okay, now it's better. Very good. Okay, now let's trace him out. Okay, go ahead. CAM. There we go. There he is. There she is. Because I was trying to use right here to help me find her, the camelopardalis. This is Cassiopeia the Queen right here. And if we notice, we look, that part of the Queen, if we trace, well, points right at the region, the dark region of the sky where the giraffe is. Another thing that helps us is if I look up, I find Auriga, the chariot driver, and I will look over, and here is, right here, this star, and a Capella, a good bright star. I see the three little lambs, or the kids, which means that I want to jump over to the other side of Auriga. These three are perfectly in line, and they're going to help me point right down to the giraffe. So notice I used other things to help me to find how to see the giraffe, okay? Another thing, look over here. What's this poking up? Ah, the Big Dipper. Well, I tell you what, let's do this. Let's use the pot of the dipper, and let's go from the opposite side of the handle to the opposite side over here of the pot. Use the lip star and the diagonal, and look at the diagonal. It points toward the part right there. How's that? That was a supernova, I guess. Okay, questions? All right, what's our next one? Leo Minor, the little lion. Okay, by the way, I forgot to mention, as everything turns, fasten your seat belts. If you do not have a seat belt, grab the person next to you. All right, here we go. Now, Leo Minor. Now, what is that? Pardon? Okay, don't press down on the light shoes. Take them off. Okay, what's this up here? The Big Dipper. Remember we used and we went on this to give us a diagonal. Up in here was what? We had the giraffe is up in here. And so now we're going to come and let's go down out of the bottom of the pot. And as we go down, we're going to come, and the first thing we're going to come to is, I want you to see. Do you see two stars right here? Do you see two stars right here? Okay, and do you see two stars right here? Two, two, two. These are the three of the feet, the foot pads of the big bear. Ursa Major, the big bear, right there. Well, we want to get below the bear, and we come down, and right here is Leo the lion. Right here. There's his head, the backward question mark. So that means the little lion, go ahead and trace it. Someone please ask whoever it is. If we have to, we'll turn on the lights. Okay, here is Leo Minor. Right here, not a whole lot there. Easy to find. Find the feet of the Big Bear. Okay? Come down, go on down, keep going south, if you will, or away from it, and there is Leo Minor. Questions? Leo Minor, little lion, is right above, in the tree right above Papa Lion. All right? What is our next one? The sextant. Okay, that's what I used when I flew in the Air Force. Okay, let's see what we have. Look up above. Big Dipper. What do we have? What's here, here, and here? The feet of the Big Bear. What's right here? Little Lion. What's right here? Big Lion. So what does that mean? The sextant has to be down. Let's draw it and see where they have it. S-E-X right here. Look at here, the Big Lion, and right below him or her is the sextant right here. Not a whole lot there. Turn it off and let's take a look. Okay, I can see these two stars, actually these three, if I look over here. If I keep looking here, they pop out for me. If I look right at it, I lose it. You notice how that works? Okay, so that's the sextant. Let's count. What have we had? What was the first constellation? Number 1 was Camelopardalis, the giraffe. What was number 2? Leo, the little lion. What's number 3? Right here, the sextant. So we're going, what's number 4 now? Pyxis. We're going to get down into the rich region of the sky. We're going to look for now Pyxis, and that is the what? The compass. The compass of Argo Navis. By the way, here is the southern line, if you will, of our Milky Way galaxy that we have down here. Over to your right, here is Orion. Here is the big dog. Here is the brightest star in the night sky, Sirius. Traveling on down the Milky Way, we're going to come down into the region here of where Pyxis is going to be on the top of the ship Argo Navis. So let's draw it. It's just a line virtually. There we go. Okay. It's Pyxis' sail. Right, Pyxis is a sail. Okay, and here we have, okay. Go ahead and turn it off. Let's get ourselves oriented, if we will, and as we come up, right up here, here is Leo. What's below Leo? Here's the sextant. And then we come further on down, and then this region right in here, go ahead and draw it again. Right in here should be, here he comes, should be Pyxis. And we're going to have now the ship and Carina and all down in here. Okay, that's number 4. Let's go to the 5th one. Antlia, the air pump. Huff and puff. Okay. Now, it's not going to be a whole lot, so let's draw it in. There you go. I think that must be about the tube that you stick into the tire to pump it up. Not a whole lot there, but here is Antlia right here, the air pump. Reference, Leo, Sextans, Vela, or pardon me, Pyxis, and then we have Antlia. Okay, we have another one, Vela. It's going to be, go ahead. Here we go, Vela. Here is, well, okay, Vela is actually the sail. I had backward. Then Pyxis was the compass. Here's the sail. The ship was here. All of this is the ship of Argo Navis, and they split it up. Now, we have an interesting thing here as we look. Go ahead. We have that, and you can turn that off. Now, I want you to look with me, and I'm going to trace something out. If I go across here and go right here, what do you see that I'm drawing? A cross. Very good. Would you want to use this to navigate with in the southern sky? No. This is called the false cross. F-A-L-S-E. The reason that's the false cross is because here is the true cross. This is the southern cross right here. And if you will take, and this line right here, it will point to the South Pole in the sky. And you can navigate with that. What will happen if you navigate with this one? I hope you have a lot of food. That's the false cross, and many navigators, ship captains in years ago, and some even currently, have used the false cross and gotten themselves lost. Now, as a navigator in the Air Force, I was never lost. However, every so often, I would get mighty disoriented. Okay? But I never admitted to being lost. Okay, here we go. So let's draw back in, if you will, Vela. You can see where, right in here, helps you pick out where Vela is, because we have the false cross, the true cross we have down here. Vela. Okay, turn that off. And our last one should be Carina. And Carina. So let's draw in Carina, the keel, the whole thing, the whole schmear. Here it is. And we have right there. Okay? All right. That is our, let's see, 1, 2, 3, 4, 5, 6, 7 constellations, right? Okay, let's work our way back up to the north. What is the name of the last constellation? This is the test. Carina, very good. Let's draw in Carina right in here. Okay, that's our ship. We do need something to sail with, so what we must have is what? Vela, the sail. So let's draw the sail. That's number 6. Well, another thing we're going to need is what? It's the next one. What's the next one up? Antlia, the air pump. This ship that we're on is a rubber raft, and so we got to pump that dude up. So let's get the air pump out. Okay, stick that thing in there. And now to navigate with, I used was a compass, Pixis. Da-dum-da-dum. Doesn't look like a compass I use, but I'm game for anything. 7654. Let's go to the next one. What's our next one up? Oh, the tool that I use the most, the sextant. And let's get it out. Yes, indeed. And let's go then the next. And what did I see when I looked through the sextant? What's our number 3? I saw the, go ahead and trace him, the little lion. And then the next thing I saw was what? Number 2. Or number 1, excuse me. Roaming the around there was, here we come. Now, before Rebecca puts up this there, let's see if we can find, if you can find where, what is it called? The giraffe, the camelopard. Very good. How do we find it? What's up there that's going to help you? The Big Dipper. What do I do? Which line? What corner? Of the pot. There you go. Bottom right, top pot. dot, 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 dot. And using Cassiopeia, and I should intersect right here, Rebecca. Let's see how good we are. Oh, look at there. Well, I think you all passed the test. Congratulations. Any questions before we bring up the lights? Are we what? Are we moving? Grab the person next to you and see if you are. Okay, thank you very much. See you in February, the last Saturday of the month. Appreciate you coming. I think we'll bring up the lights, and then I tell you what, Killian, can you bring up for fun what we have the time for a roller coaster? Okay, now you do have to fasten your seatbelts on this, because we'll do a roller coaster for you.